Before that, we had discussed about electric field lines, isn't it? So I hope now the idea of vector and all is clear. The properties of electric field line is also clear. Yes. Okay. See, I'll tell you something. The next topic that we are about to start is very, very, very important in context to board. All right. That is dipole. We have already discussed about intensity of the electric field and all these features of electric lines of force, right? They originate from the positive charge, they sink in the negative charge. They're always perpendicular to a conductor. They enter a conductor. So one more thing, if there is a conductor, no, you know that the charge is always going to remain on the surface only. So the electric field lines always originate and they move. They are always perpendicular to the surface. All right, they're always perpendicular to they enter or they come outside, always perpendicular to the surface. Inside a conductor, the electric field is zero. Yes. Any problem in all of these? Why they're perpendicular? Because suppose if they're not perpendicular, suppose if they're at some angle theta, then what will happen? There will be a component along the surface and there will be a component perpendicular to the surface. Yes. And if there is a component along the surface, imagine this is a surface and there is an electron over here and there is an electric field also whose component is along the surface. This electron will start experiencing a force. Yes or no? Correct. So this electron will start to move. And if it moves, it is no more electrostatics. It becomes current. No, did you understand? Did you understand, guys? We are talking about electrostatics, no? That is why, to make it consistent, the electric field lines always emerge or get settled inside a conductor perpendicular to the surface of the conductor. Clear with this?
Yes, sir.
We also know a tangent to the electric field at any given point gives you the direction of the electric field. We have discussed about the electric field lines, isn't it? No problem with all that. Shall we go to the electric dipole?
Yes, sir.
Any problem, any doubt in in the part that we have done till now? Electric field intensity, electric field formula, electric field lines, all the properties of electric field lines. Okay, I'll just read out some of the previous year's questions so that you know what they're asking. Okay, so this is a question that has been repeated 3 times. The question is, why do electrostatic field lines do not form a closed loop? I hope you all know the answer to this. They originate at positive charge and they sink in the negative charge, correct? So the origin point is different and the point where they terminate is different. That's why they cannot form a closed loop. And then we draw a small diagram to show that one positive, one negative, correct? Another question is, two equal balls having equal positive charges, Q coulombs, are suspended by two insulating strings of equal length. What would be the effect of the force when a plastic sheet having dielectric constant is inserted between the two? I hope you know that. What will happen to the force? What would happen to the force? It will become K times less, yes? All of you are knowing that? Yes, I'm discussing about the previous year's board questions, guys. You all have the book, no? You all have the previous year's question bank, right?
Yes, sir.
Just open it. Start looking at the topics that I have already taught you quickly. I'll just open here. That's one thing that we can do. Just a second, I'll stop share. In the meantime, you guys quickly get your question bank. Already downloaded it somewhere. Mm-hmm. Did you guys get it? Okay. Are you able to view the screen?
Yes, sir.
Yes. So if you can see, draw the pattern of electric lines when a charge minus q is kept near an uncharged conducting plate. I think all of you can do that, right? Electric field lines. Yes. If you want to check all these electric field lines, it's also given in your notes, guys. Okay. Draw a pattern of electric field lines due to two positive charge placed at a distance d apart. Check your notes. Everything, all that has been asked is there. Can you see that? If you guys open the notes, I've shared your notes, right?
Yes, sir.
Then see question number 4. Why do electric lines do not form a closed loop? Clear with this? Because a tangent to the electric field lines means that shows the direction of the field lines, and basically their termination point and starting point is different. Then this question, two equal balls having equal positive charge q coulombs are suspended by two insulating strings of equal length. What would be the effect of force on the plastic sheet inserted between the two? The force will become k times lesser. Why do two electric field lines never cross one another? Because the tangent shows the direction, and at the same point, they cannot have two different directions. You all are getting the answers? Yes, everyone? Is there any query? Tell me.
No, sir.
Why must electrostatic field at a surface of a conductor be perpendicular to every point? So if they're not perpendicular, then a component of the electric field lines will be along the surface, which will apply a force on the free electrons present on the surface of the conductor. Hence, the electrons will start moving. Thus, the condition for electrostats will get violated. Did you understand? Everyone, yes? Guys, you need to answer.
Yes, sir.
Yes, sir.
Yes,
Got
sir.
it.
And now when we start with the dipole, then dipole is also very, very important. You will understand why. Define dipole moment. Draw a plot showing the variation of electric field with R. We know E is equal to KQ by R square. Yes. So the plot will be like 1 by R square. Correct? All of you know that graph? No, 1 by X square graph. Then you see why I told you that electric dipole is very, very important. Electric dipole of length 1 centimeter placed along the axis, electric dipole in a uniform electric field. You all can see that, right? Metal sphere, point charge plus Q kept in the vicinity of an uncharged conducting plate. So many times it has come. Two concentric metallic shells of radius R and 2R are given Q and Q2 charge. The surface charge density on the outer surface of the shells are equal. Determine the ratio of Q1 is to K2. This is a question from potential. Calculate the amount of work done. The question on work done. I think if you look at here, 2 marks question for electric field due to a dipole. Electric dipole. Electric dipole question number 18. You can see, no? So many questions on dipole. A dipole with a dipole moment of magnitude P. A dipole is present in the electrostatic field, magnitude 10 to the power 6. Getting it, guys, everyone? Yes? Electric dipole kept in a uniform field. Derive an expression of electric field at a point on equatorial line of an electric dipole. Axial line of an. Derive an expression of electric field at a point of equatorial line of an electric dipole. Got it? Which means the next part that we are going to do, basically why I wanted to share you all that is, the next part that we are going to do is super important for your board exam. Correct? From dipole, you get the derivation, you get the questions also. So let's understand dipole properly, because you can be certain that one question will definitely be from dipole only of all the exams that you are going to give henceforth, whether it is school exam, whether it is board exam. Because if something is very important for the board exam, it is definitely very, very important for your school exam as well. Okay. So shall we start with electric dipole?
Yes, sir.
Okay. Electric dipole is simply two equal and opposite charges separated by a small distance. You can just imagine a molecule like HCl. You know, Cl is more electronegative. So if Cl is more electronegative, in this case, the electrons have been shared. It's a covalent bond. I hope all of you know basic chemistry of this, right? Correct? So chlorine is more electronegative. So what chlorine will do, it will shift the electron pair slightly towards itself, making it slightly more negative. And thus this H plus will get delta plus. Correct? Now this is at chemistry level. If I look at it from a distance, from little bit far away, I'll only be able to see a positive charge center over here and a negative charge center over here. Yes or no? Correct? Correct, no? Now I see two equal and opposite charges separated by a small distance, and this is called a dipole. Di means two, pole means polarity. Got it? No problem? Okay? Yes, everyone is okay with this? All right. So all of you understood, know that how you get a dipole. So what is a dipole? Dipole are two equal and opposite charges separated by a very small distance. Now we won't see H and Cl molecule and all that. We'll just see two equal and opposite charges separated by a small distance. All right. So a dipole is like, you can have plus Q, you can have minus Q. This will be called as the center of the dipole. The distance between the two charges, is, let us say, 2L, and from the center, which I am calling it as O, let's say this charge is at a distance of L, and let's say this charge is also at a distance of L. What is the total distance between the two charges? 2L. Did you get it? Okay. Now, how about this dipole? So overall, how it is going to behave, basically. You know what is the speciality of a dipole? It's that suppose n number of field lines are coming, they all will sink here, right? Whatever field lines are coming like this, They all sink here. Correct? Yes. So overall, if you take a dipole very far away, if I look at from like this, I can see the net charge is equal to 0 because whatever is coming out is going in, right? Correct? But the field lines extends up to infinity, no? The field lines extends up to infinity like this. It keeps on extending up to infinity. So what happens even at this point, if you see, there will be electric field. Although the net charge seems to be equal to 0. Are you understanding the basic or the speciality of a dipole? Although when I'm looking at it from outside, I see that the net charge appears to be equal to what? 0. Did you understand? Yes. But at any given point, there is electric field. At any given point, there is electric field. At any given point, there is electric field. That's why dipoles are special. No problem. Now, how much will be this electric field? If I place a charge, I know my charge is going to run like this. If I place a positive charge over here, I know my charge is going to run like this because there is electric field, right? If you see this region, there is a region of electric field, isn't it? So if you place any charge over here, it is going to run. Now, in which case the charge is going to run faster, which means I want to know about the strength of the dipole. How do I talk about the strength of the dipole and how two dipoles are going to be different from one another? Did you understand this? Did you understand this? So strength of a dipole is given by a vector called as dipole moment. A dipole moment, all right? So this is, let us say, positive charge. This is, let us say, negative charge. We have defined that this is the center of the dipole. This length is L. This distance is also L. So they are equidistant from the center of the dipole. Let me just draw two lines like this. So charge is Q. This charge is also Q. Dipole moment vector is defined as magnitude of or value of one of the two charges times the distance between the two charges. And its direction is always, remember, its direction is always from negative towards positive. Always, this is the direction of the dipole. Clear with the idea of dipole moment? So dipole moment is a vector quantity. The direction of this vector quantity is always from negative towards positive. The value of the dipole moment is value of one of, because both the charges are equal, charge times the distance between the two charges. Q into 2L. Got it, everyone? Amartya, you were confused with the dipole, no?
Yes, sir, got it.
Now things are making sense, yes? Okay.
So could you repeat the definition for dipole moment?
Dipole moment is defined as the product of value of either of the charge and the separation between them. And the direction of this dipole moment vector is from negative towards positive. Always from negative towards positive.
No, so but like apart from numerically, what exactly does it mean?
So for example, see, like if you want to see, like there are interaction between two dipoles, okay? Like one dipole I have placed over here, another dipole I have placed over here. So what is the net field? How do I find that out? Did you understand? So you can't,
Okay, so you use the
you
dipole
can't,
moment.
you won't be able to displace the dipoles, no? But if you have got
Right.
one dipole like this, another dipole like this, and if I want to know what is the net effective dipole moment over here, what is the effect of electric field over it, I can very easily talk in this term.
Okay.
Did you understand? If
Yes,
I
sir.
say that there is a dipole along x-axis, there is another dipole oriented along y-axis. Correct. So
Yeah.
there will be a net dipole. You can replace these two by a net dipole. So now we'll say that, okay, there is a net dipole and we'll see the effect of all the electrical phenomena with respect to this dipole. That is why
Okay.
we are not able to see the dipole. Rather, we start seeing the dipole moment.
Right.
So that when we about the electric field, we always write it in terms of the dipole moment vector. All right.
Yes, sir.
Clear? Anyone has got any doubt? See, dipole is super important. It's super easy, but once you understand it, then only. Otherwise, you remain confused throughout your life. You never understand dipole. Either you understand it completely or you don't understand it at all. All right. I want you people to be the first case. You understand it completely. You understand it once, that's it. Because there are similar things that you're going to learn later also, which is called as
Yeah.
magnetic dipole. Very, very
Sir, I'm
similar
a
to
little
electric
confused
dipole.
with these concepts of dipole.
Sorry, Pranav, I didn't
So
get
I'm
you.
a little confused with those dipole concepts, sir.
Which concept?
And the dipole like, moment concept, I'm confused with those. Yeah. So it will be better if you revise it again or just a glance.
Okay. So dipole basically is nothing but two equal and opposite charges separated by a small distance. All right. How we can imagine such a charge is by looking at a molecule like a HCl molecule. So chlorine is more electronegative. Chlorine is stronger than hydrogen. So this is a bond which is a covalent bond where they were sharing these electrons. But what happens since chlorine is stronger, it is able to attract this shared pair towards itself, making it slightly more negative, and hydrogen now becomes slightly more positive. If you look at this scene from little bit far away, you feel as if there is a negative charge over here and you feel that there is a positive charge over here. So in physics, this is the picture that we want to see. In chemistry, this is what you see. Did you understand? So when I see, I'm supposed to see only the charges. I see a positive charge and a negative charge. So there is a separation between them. So two equal and opposite charges separated by a small distance will be called as a dipole. Di means two, pole means polarity. Clear with the definition?
Yes, sir.
Now I zoom into this picture and I only see the charge. I say, let's say the charge is plus Q, minus Q, and I join them with a straight line. And I say that there is a center of the dipole and I name that center as O. And I'm saying that from the center, both of them are equidistant, which means positive charge is at a distance of L, negative charge is also at a distance of L. No problem. Now, when I look at this dipole from outside, I need to take care of the strength, because every dipole is not going to be same, right? But all of them are going to have some charges and some separation. Correct? Did you understand? For example, if you think
Yes.
about this molecule Cl2, Cl2 is not having a dipole. Why? Because this is chlorine, this is also chlorine. So they're equally sharing the charges. Did you understand? There is no imbalance. So this is not a dipole. But if somebody says, what we can write, let us say, if somebody says, let us say H2SO4, a molecule like H2SO4. So you know this is 2 minus, this is 2 plus. So this also looks like a dipole. Correct?
Yes.
So how is this dipole different from this dipole? Which is more stronger? How do I define the strength of the dipole? How do I compare two dipoles? For that, we introduce a term called as dipole moment. Clear? Okay.
Sir.
To measure the strength, we call that, we introduce a term called as dipole moment, and we define the dipole moment is going to be what kind of a quantity? A vector quantity. But now suppose who is rich and who is poor, how do we decide? We decide based on the money that he has, right? So we introduce something called as money and property. And then we start comparing, no, that, okay, the guy who is having more money, more property, he's rich. Correct, no?
Yes.
So like that, we define this term dipole moment. The definition of the dipole moment says that the magnitude of this vector will be charge, value of one of the charges, not with negative, positive. Value of one of the charge times distance between the two charges. And what is the distance to L? That's how we have defined it, right? From the center, if one is at a distance of L, the other one is at a distance of L, the total distance between them is 2L, correct? And the direction, we have fixed the direction. It will always be from negative towards positive. Got it? So that
Okay.
every time I don't have to draw this diagram. Every time I don't get to draw this diagram, I can directly draw the dipole moment and it will be clear where is the negative charge, where is the positive charge, which is having more strength. Got it? No?
Yes, sir.
Okay, everyone has got a clarity on this?
Yes, sir.
Okay. Any questions on till dipole moment? No, right?
No, sir.
Okay, good. Now, next thing is, let us say this is minus q plus q, anything you can put. Plus q. Let's say this is minus q. This is the line joining the two dipole. This is the center of the dipole. Everything we'll measure it from the center only. This length is L, this length is L. Now, a line which joins the two dipole and extends. A line joining the two dipole extending is called as an axial line. Did you understand?
Yes, sir.
Yes, I think every one of you have switched off your camera, so I'm not able to see. Okay. So a line joining the two dipole along with the center along this is called as an axial line. Any confusion with the axial line, guys? What is called as the axial line? Elvin, Amartya, Rishi.
Yes, I got it.
Line join.
Okay. A line joining both the positive and negative charges and extending like this is called as the axial line. And a line perpendicular to the axial line passing through the center of the dipole is called as equatorial line. Did you understand the two lines? The meaning of the two lines is clear, guys? The line joining the two charges and extending like this is called as axial line. The line perpendicular to the axial line passing through the center is called as equatorial line. Clear with this? Okay. Now what they will ask you? They are going to ask you the same thing again and again. They will ask you, find the expression of electric field intensity at a point on the axial line. And find the electric field intensity at a point on the equatorial. And that's what this is the derivation that we are going to do, which is super important, very, very, very important for all the exams henceforth. But did you understand the premises? Everything is clear now? What we are going to do? No problem. Any issues, guys? No issues? Yes?
Yes, sir.
Shall we go ahead?
Yes, sir.
Okay. Now, let's do that derivation. Axial line. Electric field for dipole. Understand the derivation. Everything is written in your notebook, so don't worry. We can take this direction as I cap if you want. If you don't want, that was also okay. But let's say this is plus q. Let's say this is minus q. This is our axial line. This is the center of the dipole. This length is L. This length is also L. Let's say at some distance here, I take a point P, which is at a distance of x from this, from the center. No problem. Got it? Okay. So, if I want to write the electric field, because of this plus q at this point, what I'll write? Electric field because of plus q will be what? Kq upon r square. And what is the distance r from this charge? What is the distance? This is L and this is x. So can I write it as L plus x square? Is it okay? Yes? Following it, everyone?
Yes, sir.
Sir.
And if I imagine that I want to find the electric field because of this plus q charge, which means I will imagine a unit positive charge over here, unit positive charge on which the electric field will be in this direction. Yes or no? Yes? Correct? So this is electric field because of plus q. And this is the value. What will be electric field because of minus Q? Because of this minus Q. Electric field because of minus Q is going to be equal to KQ. And how far it is away from minus Q? This much. Can I write this as X minus L? This distance? From here, it is X. And this much is L. So is this length not X minus L? Are you getting it, everyone? Guys, are you
Yes.
getting this?
Yes, sir. Yes, sir.
Derivation seems okay, no? Till now?
Yes, sir.
So I can write here.
The derivations
What?
are taken from the charge at point P, right?
Sorry?
Yes, that's x the whole square and x minus l. So it is taken from the charge to the point P, right?
Yes, obviously. For any, if you want to get the value of the electric field, you always take the distance from the charge to that point, no? KQ by R square. Remember that formula,
Yes, sir.
correct? So in this case, R from this charge is X minus L because we have taken every distance from the center of the dipole, no? Correct? So X minus L whole square. And what will be the direction? The direction of this electric field will be in this direction. Can I say that? Of course, because this is negative, and if I want to find the electric field, I'll always put a unit positive charge over here. So unit positive charge will be attracted. So this is the direction of E minus. Can I say that? Yes. Guys,
Yes, sir.
any problem? Any problem? Any problem till here?
No, sir.
No,
So
sir.
what will be E net? E net. E net is going to be equal to, and I can also write this if you want to take this as positive I cap. I can write this as I cap. I can write this as minus I cap. No problem. No problem if I take this direction as X axis. So this direction will be I cap. Correct? No, this is my X, this is my normal Y. Correct?
So
This
here
will
we
be
don't
minus.
have a specific value for I cap, right? We're assuming
I
a
cap
value,
is,
right?
no, we always do that, no? We choose our coordinate system, no? We always do that.
Oh, okay, yes, sir. Huh.
So E net vector, now if I want to write it in terms of vector, that's why I have put I cap or minus I cap. E net is nothing but E1 E because of plus vector plus E because of minus vector, minus Q vector. Yes. Superposition principle. Yes or no? Can I write this plus Q as KQ by L plus X square? And this is minus I cap. This can also be written as minus KQ by I. Correct? No? Just showing the direction, isn't it? This minus this will be the net. That's what we want to say. KQ by L minus X square. Yes or no? All of you are getting it? All of you are getting it? Yes or no? Tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now if I solve this further, see what happens. What you
Sir,
can write? Huh?
sir, for the E plus Q, wouldn't it be KQ by L plus X the whole square?
Ah, yes. Sorry. Yes. Correct. Okay. Can I take KQ outside? If I write like this, L minus X ka whole square minus L plus X ka whole square divided by L minus X, yeah, L plus X ka whole square into L minus X ka whole square. Is it okay? Is this okay, guys? Tell me.
Yes.
Yes, sir.
Okay. Now let's solve this further. What do you get? See what you're going to get now. So if I write this, this will be L square, A square minus 2ab plus b square. Yes. With a minus sign, this will be L square plus 2ab. Correct, no? Plus b square. If I put this minus sign inside, then see what will happen. This will become minus. This will become minus. This will also become minus. Correct, no? Plus x square minus x square cancels. Plus L square minus L square cancels. Minus 2lx will give you what? Minus 4lx. Yes or no? In the numerator. Outside you have kq. And in the denominator, what you have? In the denominator, what you have? A plus b into a minus b ka whole square. Can I also write this whole thing as a square minus b square ka whole square? See, this is a plus b ka whole square, a minus b. A plus b into a minus b can be written as what? A square minus b square. Yes or no? So can I write this as, are you all following this, everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Can I write this as a square minus b square? Ka whole square. Oh, sorry, it should be opposite, no? L square minus x square. L square minus x square.